We first have the breaking headlines and then we shift to future predictions with mathematical analytics. So here goes the biggest headlines. Big blast in Palampur. NSG and NIA investigating up the case. 9v2 exhibition news had a successful sting operation on black marketers. 5 arrested for the same. Now we have the biggest breaking news of this morning coming directly from across the globe. World suffering due to a havoc created by global warming. Painful pics coming from around the world. World suffering due to a havoc created by global warming. Painful pics coming from around the world. Now we have a short coverage of videos directly coming from the affected sites. Now, with more information on the story, we have our ground reporter Pratyush reporting directly from the affected sites. So Pratyush, if you can hear us, kindly describe the situation which you have experienced.
Yes, Ruksha. See, the condition around the world is more worse, and that was pitiable that you can see here the barricades have been placed so that even media cannot enter these premises. If I come to the level of damage that the world has taken due to this series of avalanches and forest fires, so let me inform you that there are lakhs and lakhs of deaths which are happening every month around the world, and therefore crores and crores of properties are also being lost. See Ruksha, this is a concern to be taken very seriously, as if we don't take any step forward, a big step, then the human species may get extinct.
So very important points covered by our ground reporter. Now, for more discussions on the various concerns and predictions with mathematical analysis, we invite Dr. Anand, the CEO of Predictor Guru, who will be answering to our ground reporter.
So Dr. Anand, welcome to our show. So first of all, please inform us and our viewers that what are the concerns that you are looking for.
First of all, thank you for providing me with this stage. Basically, currently the whole world is facing a series of threats, which is directly or indirectly caused by people only. What I need to say that, please be aware.
So Mr. Anand, your company is so famous for your predictions, especially based on the future which might have been affected due to these horrible events. So we request you to provide some of the mathematical analytics and predictions of your company based on these events.
As we can see, the population of India is rapidly increasing and so has the demand. This has led to heavy consumption, which is too large to be fulfilled as the population is massively increasing. Also, my prediction predicts that by year 2030 to 2035, Mumbai will be submerged under water as global warming continues. And also it will lead to series of famines, loss of people, and most importantly, the economy of India will shut down to its bottom. Thus, if no solution is being taken place for increase in the population and increasing in the global warming, then we may have food crisis and also subsistence crisis. So please be aware. and please help others.
Thank you, Dr. Anand, for debating with us.
That was all for this show. Hope the spectators would have enjoyed it and may have learned about the concerns which are being indirectly caused by us. Till then, stay at home, stay safe.
Let's relate mathematics with agriculture, prediction of climatic conditions, and control of pollution. Vishnu is a very good boy and is very eager to learn mathematics. He relates everything around him with mathematics. Scene 1. On a fine day, he became very keen to learn how mathematics is beneficial for agriculture, and then his friend Swasti calls him and solves his query.
Hello, good morning. What are you doing?
Good morning. Do you know I was observing now the paddy fields and I had a question that how will be this mathematics useful for agriculture?
Don't worry. I have been researching for a long time. Let me tell you.
I was eagerly waiting for this.
Mathematics is very important in agriculture and is vital to all farmers alike. It is used in measuring soil fertility and calculating profit and loss for the crops. Then it is used in measuring the area of the field. Even it is used in estimating crop yields. So like this, mathematics is used in agriculture, and until and unless we don't think about it, we will not be able to relate it.
So, like this, we got to know about agroscience. Scene 2. On another day, Vishnu saw the news on the television about climatic prediction and wondered how climatic predictions are calculated. Suddenly, his friend Vidhi called him and explained how it is calculated.
Hello, what are you doing?
Do you know today I saw that Mumbai has 37 degree and Delhi has 38 degree. But I am really puzzled at how these climatic predictions are calculated.
Don't worry, I even asked the same question to my father as he works in the meteorological department, and he told me some ways by which we can calculate climatic change.
Please tell me those ways.
Climatic change is a physical phenomena which is the result of intelligent physical processes. The science of climatic change can be expressed, predicted, and studied with the help of mathematics. Changes could be precipitation, humidity, pressure, increase or decrease in the total number of rainy days, etc. For this, we use statistics, which is the branch of mathematics of climatic variables like wind speeds, humidity, precipitation, etc. to show the changes. The basic climatic model is also known as energy balance model.
So, like this, we understood how climatic predictions are predicted. Scene 3. One day, when Vishnu was on the way to his village, he saw a lot of traffic on the road. He sees that due to traffic, some dark clouds are created. He thinks that his mathematics is helpful in reducing the traffic. Then, surprisingly, his friend Simral calls him and helped him to resolve his query.
Hello, good morning. Are you traveling anywhere outside?
I am on my way to village. Do you know how traffic is time wasting for us and it also produces pollution? Can't we reduce traffic and pollution using mathematics?
Ask me in the right time. I was just researching about that right now. Let us learn together.
Yeah, let's start.
Mathematics play a key role in managing traffic and hence reducing pollution. Brass's paradox is a mathematical paradox that is useful for observing road networks and give you intuitive results. MIT has discovered a mathematical equation that is useful to solve the traffic in the highway roads, which is bilateral algorithm. It includes a lot of linear algebra and vector math to calculate the road networks. And due to less traffic jams, the smoke from the vehicles is less, hence reduces the PM2 level in the atmosphere. So it is a credit for mathematics that it is helpful for reducing pollution. Thank you.
Wow, isn't it great? Mathematics is also helpful in reducing pollution.
I understood that mathematics is really very important and everything around us is mathematics.
Good morning. Today I am making a PPT on how we can save environment by using maths. Maths used in saving environment. For extracting the maximum potential of renewable resources, mathematicians help in solving the glitches associated in the management of renewable resources such as cost and operational efficiency. Following methods can save the world: designing better weather forecasts and climate models, making the most of renewable energy sources, preparing for change, making sense of big data, and developing new technologies. Mathematicians play an important role in this process, working with a set of equations that describe the atmosphere, taking into account temperature, pressure, and humidity. Mathematicians contribute to research into energy supply and demand that ensures network incorporate higher proportions of weather-dependent energy sources such as wind or solar power, making sure that light stay on in years to come. The effects of climate change will be felt on many levels, and knowledge is the key to safeguarding human health and livelihoods as we adapt to changing circumstances. Businesses also need detailed information on how climate change might affect them. Moreover, mathematical simulations are a valuable tool for estimating the possible consequences of specific actions by playing out different scenarios. Collecting billions of pieces of data and environments, from ice sheets to cities, can deliver precious insights into a planet's physical process, human behavior, and everything in between. Climate scientists rebuild the history of a planet's atmospheric composition by analyzing the tiny bubbles trapped in ice records in order to anticipate the scope of future changes. New technologies are a key to low-carbon future. Carbon capture and storage, for instance, could safely lock away greenhouse gases emitted by fossil fuel-fired power stations and is likely to play a key role in averting dangerous level of global warming. Thank you for watching.
Greetings to all my respected teachers and my peer mates. Mathematics, as an expression of the human mind, reflects the active will, the contemplative reason and desire for aesthetic perfection. Its basic elements are logic and institution, analysis and construction, generality and individuality. History of mathematics. The study of mathematics as a demonstrative discipline begins in the 6th century BC with the Pythagoreans, who coined the term mathematics from the ancient Greek mahoma, meaning subject of construction. Islamic mathematics in turn developed and expanded. In our inquisitive minds, we may have a query that can maths predict our future? Actually, the answer is yes. It gives us a way to understand patterns, to quantify relationships, and to predict the future. Math helps us understand the world, and we use the world to understand math. The world is interconnected. It can also predict profits, how ideas spread, and how previously endangered animals might repopulate. Now let's see the different scopes of maths. Maths can be used in many fields of our life. For example, medical sciences, cosmology, architecture, advanced technology, and banking sector. First, medical sciences. Medicine has become increasingly relevant on mathematics in recent years. Differential equations and statics have long played a role, but recent medical advances have involved the use of mathematics in new and exciting ways, such as the role of geometry and topology in modeling potential drug targets. Second, cosmology. Robertson-Walker geometries are spatially homogeneous and isotropic universes, representing the geometry of the universe on the largest observable scale. They are everywhere spatially homogeneous and isotropic, and so have no feature anywhere. They are characterized by a scale factor. Third, architecture. Geometry, algebra, and trigonometry all play a crucial role. In architectural design, architects apply these math forms to plan their blueprints or initial sketch designs. They also calculate the probability of issues the construction team could run into as they bring the design vision to life in three dimensions. Fourth, advanced technology. Mathematics is the universal language of science and technology. The world around us is pervaded by maths and its technological applications. Bridges are built using mathematics and steel. Mobile phone signals are encoded using mathematics. And your credit card is encrypted using mathematical models. And at last, we have banking sector. Extensive maths is involved in keeping track of the money in a bank. Banking is a world of numbers and mathematics is used in the way accounts are handled for calculating interest rates and for determining credit scores. Mathematics and banking are tightly linked. Banking requires constant use of mathematics. Thank you.
The environment seems boundless and there is no definite answer to this mystery. But we, in the capacity of curious species, try to understand the environmental issues through the lens of scientists. But not many try to find solution to the environmental issues with the help of mathematics. Numbers are inanimate designs that can be easily reproduced on paper, but they hold the immense power to crack the most difficult problems in world, including environmental issues. In last 30 years, from 1990 to 2020, more than 12,000 of trees were depleted in India. Main reason for depletion of forests are urbanization and increase in commercial use of wood, bark and timber. Collection of firewood in rural areas lead in depletion of forest. On the other hand, air pollution has now become the main source for depletion of But disruption caused due to COVID-19 virus has resulted in numerous positive effects on environment and climate. The global reduction in modern human activity has caused a large drop in air pollution and water pollution in many regions. In China, lockdown and other measures resulted in a 25% reduction in carbon emission and 50% reduction in nitrogen oxide emission, which scientists estimated may have saved at least 77,000 lives over 2 months.
Mathematics, a tool of future. Introduction. The progression of both the nature of mathematics and individual mathematical problems into the future is a widely debated topic. Many past predictions about the modern mathematics have been misplaced or completely false. So there is a reason to believe that many predictions today may follow a similar path. However, the subject still carries an important weight and has been written about by many notable mathematicians. History of mathematics. The area of study known as the history of mathematics is primarily an investigation into the origin of discoveries in mathematics and, to a lesser extent, an investigation into the mathematical methods and notation of the past. Before the modern age and the worldwide spread of knowledge, written examples of new mathematical developments have come to light only in a few locals. Some skills which improve mathematics: conceptual skills and professional skills.
Mathematics and daily life. Mathematics helps individuals to figure which bank is giving better revenue on their venture for a particular period. With the assistance of mathematics abilities, they can ascertain straightforward and accurate funds without much of a stretch. The universe of mathematics encompasses you. Problem solving capability. Application of appropriate strategies to solve problems. The use of appropriate mathematical tools, procedures, and representations to solve the problem. The review and proof of a correct, reasonable mathematical solution given the context. Mathematics as a language. In order to be considered a language, a system of communication must have vocabulary, grammar, syntax, and people who use and understand it. Mathematics meets this definition of a language. Linguists who don't consider math a language cite its use as a written rather than spoken form of communication. Math is a universal language. The symbols and organization to forms equations are the same in every country of the world. Thank you everyone. This PPT was made by Pranav Bharadwaj and Nitya Gosai.
Hello everyone. Today I, Kritika Soni of class 12th is here to tell you something about safe environment, in which I am going to show you some type of energies in which we can use maths to save the environment. So let us begin with the solar plants. Solar panels use less water, reduce air pollution, and also help to slow the climatic change. But how we can use maths in it? We can use maths by measuring the angle theta between the solar panel and the ground. In case of solar panels, to get their best performance, a steep angle of 60 degree is best. During the spring, the best angle is 45 degree. And during the summer, when the sun is high in the sky, it's best to have a low angle of 20 degree. This is the maths that we use in solar panels to save our environment. Now let us talk about wind energy. Maths contribute to research into energy supply and demand that ensures network. Maths also ensures that these technologies harvest the maximum energy as efficiently as possible.
We all know about math, but do we know about its history? So dear viewers, allow your navigator Prisha Jha of 10th B6 to navigate you through the history of mathematics. So let us begin. So how did mathematics begin? Early Paleolithic humans had found a way to mark the time by developing a number system. After every major change in the season, they used to mark a line on their walls with the help of an object like a stick or a stone. This helped them in keeping a note of the time that went by, a line for a unit, and so on. But this system was not efficient for large numbers. After all, how many lines could a human make? This efficiency was sorted by the help of symbols. They made conical clay rocks as a unit 1 and the round rocks as a unit 10, whereas a larger rock may be numbered as 100. All these things were marked evident on their stones and their inscriptions. Eventually, they came up with the idea of written symbols. They came up with the idea of side V as 10 and the flask as 1, eventually writing the number 19 as shown on the screen. The early Egyptians used real-life objects as numbers, like a rod would equal to 1 and a cable hobble would equal to 10. A coiled rope was 100 and a lotus flower was 1000. The early Romans came with the idea of grouping where X was us and I was them, eventually leading to X was 10 and I was 1. By adding the units, they used to write as xy equals to 10 and ix equals to 9, xix equals to 19, and so on. This system, we follow it till the date. Do you know that some people also use their fingers to count, like ones, tens, hundreds, and thousands, or the first 5 fingers? When the counting on the right hand started, it meant that the counting on the left hand is over, and no more fingers are left to count. New numerical system began in Africa and Nigeria, where the people used some necklace type things which had some shells on it. They used to compile operations like multiplication, subtraction, and addition. For example, let's say 20 times 3 minus 5. In early Persia, there were knots tied to mark and to note the number values. Doesn't this remind you of the present-day abacus? Knots were tied to mark the numbers that is given on the screen. Nowadays, we too have a habit of using these symbols from 0 to 9 as our daily life symbols. But this and the invention of zero was made 800 years back. You know, the 1000 and the 100, the zero by Aryabhatta. As we all know that we humans have the tendency to divide the things. Therefore, we got to know about fractions, that is dividing. Whether it's a piece of a loaf or land, it all began with the early Egyptians, who always used 1 as a numerator, which we call today as a unit fraction. For example, their breads were divided into halves, 1/3, 1/4, or 1/5. Let's say that the first piece of bread has been cut into 3 parts, that is 1/3 of the bread. The second bread has been cut into 5 parts, and the remaining part of the first bread, the third part, would be cut into the rest 5 parts. So, once 1/3, 1/5, 1/10, 1/15. We all share it then now. In today's language would be called 3/5. Now that we are aware of our past, keeping track of future will be easy. To improve the quality of life and create an environment in which human beings live in harmony with nature, it is necessary to evaluate the effects of human activities. And how can we do that? It's complex math. The main purpose of this department is to be found in the research and education of mathematical and statistical science. So here we could relate our mathematics with our environmental science and our environments. So from this we get to know that math is not only required in our daily budgeting and managing issues, but is also required in environment, thanks to math. Now, can we relate mathematics with the present day utility? Of course, yes. Do you know how the planes take off? Indeed, pilot and the engines are used, but what about math? Where is it used? Here it is called trigonometry. It gives us a perfect idea of how the angle should be inclined. Mathematics brings solid science to the debate. It provides confidence in climate change models and it helps us to improve existing renewable technologies. Math is also a key in assessing renewables based on observations from the environment. For example, weather data helps to predict the efficiency of solar cells.
When the history of climate change was written, the years 2006 and 2007 may be seen as a turning point, a time when climate change ceased to be seen as a green issue and became an everyone issue. Carbon dioxide levels and levels of other greenhouse gases have been rising for at least half a century. The current concentration of carbon dioxide in the atmosphere, 380 parts per million, is greater than it has been at any time in the last 650,000 years. The main question is, how do we know about these minor and major climate effects and changes? The answer is through mathematical modeling, GMIC's model, which capture minute details about the Earth-changing atmosphere and swift weather change. Generally, data and statistics through mathematical models that are description of a system using mathematical concepts and language are used frequently in natural sciences. By understanding and studying the concepts of climate change models, we could easily understand that how we can conserve our natural resources and improve our sustainable development ideas for a better future.
Hello people, I am Earth, or you can also call me environment. I am the most unique planet in the solar system. I have air, water, trees and everything, but soon I think I will get back to becoming a dark dense state just like 13 million years ago. But I am happy that many humans are trying to save me with different technologies and science. But there are some people who have extracted some tools or ideas with maths. You must be thinking that how they are extracting tools to save environment with maths. So let's start. Wildfires. Wildfires are one of these issues. They spread fast, so people need to act fast too. In 2018, more than 150,000 acres of land burned in and around Paradise, California. To make sense of the damage, officials turned to Gregory Krutzinger. He performs and flies drones or small unmanned aircrafts. He says, I love flying drones, but you need to have basic math skills in order to do the job effectively. He programmed 15 drones to fly above the wildfire in Paradise, California. They took more than 70,000 photos, which Krutzinger used to create maps of the affected areas. Officials used the map to assess the damage and plan for recovery. Organizing the drones took a lot of problem solving, but Krutzinger is glad he could help. He says a lot of people really care about their community. Protecting marine animals. Billions of people eat seafood as part of their diet, but there are only so many fish in the sea. So, to keep fish populations healthy, some governments have created marine protected areas where fishing is either limited or not allowed. But can marine protected areas help the fishing industry too? Patrick De Leon here wanted to know. He is a mathematician at Oregon State University. He came up with a complex math equation called a mathematic model. It's designed to predict where to create a marine protected area so fish can get the most benefits while still allowing fishermen to catch them. He says mathematics is a powerful and precise language. It can help us solve complex real-world problems. Hurricanes and storms. Worldwide extreme weather is becoming more frequent and more severe. Amber Emory has always been fascinated by extreme weather. Emory is a meteorologist or weather scientist at NASA. She uses math to predict hurricanes. Meteorology is applied maths. She says, when a hurricane forms over the ocean, Emory's team send an unmanned aircraft. Its 5 scientific instruments collect information about the storm within 20 minutes. The data is sent to meteorologists. We figure out where the hurricane will make landfall and how strong it will be, she says. Then the team communicates storm information to the public. Emory says, what drives me every day is making sure people are safe during a storm. Here we met all the intelligent people who are working really hard to save the environment. But how you can save 25% money from your electricity bill with energy efficiency measures? Aditya will help you with that.
These efficiency measures can be as simple as turning off the lights or appliances when you do not need them. You can use energy intensive appliances less by performing all the household tasks manually, like hand drying the clothes instead of using the dryer, or cleaning all the dishes without dishwasher and using your bare hands. Now let's do some calculation. So according to an energy analyst, it is said that an Indian average monthly electricity bill is 6,500 rupees with 8 rupees per unit. So 25% of 6,500 would be around 1,625 rupees. So our monthly saving is 1,625 rupees. Now to find your savings on yearly basis, we will just simply multiply 12 with 1,625, which is equal to 19,500 rupees, which is a very big amount.
So you see, by easy measures, you can save 19,000 rupees. Isn't it nice? By saving money, you would be saving energy and you would also be saving me.
Hello? Please send me the files quickly. I need to submit them tomorrow to the boss. Okay, thanks.
Why have you turned on the AC?
Well, we have bought it for using it only, right?
I am not joking. Temperature outside is 22 degrees Celsius and you have turned it on for 20 degrees Celsius. Why you have turned it on for no reason at all?
I'll pay the electricity bills.
It's not about the electricity bills, but the environment. Hey, I am talking to you.
Hey, listen to me. Stay a little bit less tense. Listen to that new song and stay a little bit less tense, okay?
It's been 3 hours since the power cut. When will the current come back? And also, why is it so hot all of a sudden? It's 35 degrees Celsius, which was 22 a few days back ago. I seriously want to turn on the AC now. I can't handle this heat anymore.
The temperature is suddenly so high due to the global warming. I remember a few days back you have turned on the AC for no reason at all. That also contributes. Global warming. Well, I know change in one person doesn't have much effect. But remember the quote from Mahatma Gandhi, be the change you wish to see in the world. And yeah, I am not saying don't use AC. Use it when it needed, not carelessly.
Hello everyone, this is a very serious issue. Global warming is something on which we all have written various essays, but most of us didn't take it seriously. I'm pretty sure that most of you have heard of this country called Maldives. You know what? It's sinking.
If the rate at which the seawater is rising continues to be the same, Then by 2045, Maldives may not have any coral reef left, and by 2100, it could be the demise of this paradise tourism. It will become the first country to relocate all its population as refugees due to the global climate change.
Ironically, the Maldives contributes a negligible 0.0003% to the world's greenhouse gas emissions. Who do you think would be responsible if this country sinks completely in the near future? It's us.
Countries like India, China and USA are mainly contributing to CO2 emissions. Maldives has already lost over 20 islands, more than 100 islands are reporting erosion, and around 30 islands are identified to severely eroded. If greenhouse emission continues to increase like this, then as a result, heat will be retained on the atmosphere. In 2010, scientists predicted that we had built enough carbon dioxide emitting infrastructure to the global temperature by 1.3 Celsius. They said things would have gotten worse unless we take drastic action. As predicted, things have gotten worse.
Now if we don't take any action, then temperatures can boost by 1.5 degrees Celsius. Those who are thinking about how it would affect us, here's a fact for you. An increase of 1.5 degrees Celsius in global temperature can melt nearly oceans. Who do you think would be responsible if this country sinks completely in the near future? It's us.
Countries like India, China and USA are mainly contributing to CO2 emissions. Maldives has already lost over 20 islands, more than 100 islands are reporting erosion, and around 30 islands are identified to severely eroded. If greenhouse emission continues to increase like this, then as a result, heat will be retained on the atmosphere. In 2010, scientists predicted that we had built enough carbon dioxide emitting infrastructure to the global temperature by 1.3 Celsius. They said things would have gotten worse unless we take drastic action. As predicted, things have gotten worse.
Now if we don't take any action, then temperatures can boost by 1.5 degrees Celsius. Those who are thinking about how it would affect us, here's a fact for you. An increase of 1.5 degrees Celsius in global temperature can melt nearly 2 million square miles of Arctic permafrost, destroy 70% of the world's coral reefs, and expose 14% of the world's population to bouts of severe heat, which can lead to a variety of diseases. And this is definitely not a good sign.
An article of New York Times says India's major cities like Mumbai, Kolkata, Chennai, parts of Surat can be submerged underwater by 2050 due to these emissions only. So these CO2 emissions are way more dangerous than you used to think.
We hope all of you have realized that global warming is harmful for the whole mankind and we must take a drastic action towards it before the situation becomes uncontrollable, because prevention is always better than cure.
इस दुनिया में ना तो कुछ मुश्किल होता है ना ही आसान होता है। सारा खेल मानने का है। जो मानता है कि उसके लिए मुश्किल है तो उसके लिए मुश्किल है, और जो मान लेता है कि मेरे लिए आसान है तो उसके लिए सब आसान है।
Hipparchus, father of trigonometry, study of angles and sides of triangle. Hipparchus, father of trigonometry, study of angles and sides of triangle. Alpha, beta, gamma, phi, psi, xi. Let's sing together so we can learn. Hipparchus, father of trigonometry, study of angles and sides of triangle. Alpha, beta, gamma, phi, psi, xi. Let's sing together so we can learn. First comes right-angled triangle, opposite to 90 degree, it's hypotenuse. Opposite to reference angle is perpendicular. Adjacent to reference angle is base. Some people have curly brown hair, turned permanently black. Sin is P over H, cosine is B over H, tangent is B over B. Cosecant, secant, cotangent, reciprocal of sine, cos, and tangent.